Good morning, students. In today's class, we are going to learn that is graphical representation of motion. Okay, we have two types of graphical representation of motion. That is, one is distance time graph, and another one is velocity time graph. Then, what is graphical representation of motion? What is motion first? Motion is change of distance or change of position with respect to the time. If any object changes its position with respect to time, then it is called as motion. That motion we can represent in the form of graph. That is in the form of graph. The motion can be represented in xy Cartesian. xy Cartesian is nothing but a graph. XY plane. In the XY plane, we can represent the motion of the graph. That's why we call it as graphical representation of motion. Okay. In that, first one is distance time graph. The first one is distance time graph. In distance time graph, here looking, this is the y plane, or we call it as y axis. Not y plane, this is y axis. Above this is called as y plane. Okay, above this is called as, this is what, y axis, and this one is horizontal line. Horizontal line is called as x axis, and the vertical line is called as y axis. Together what we call it as xy plane. Xy plane. Okay, in xy plane, if we represent the what is that motion, then it is called it as graphical representation. This type of representation is called graphical representation. Look here, on y axis, this is y axis. On y axis, we taken distance in kilometer. On y axis, we taken distance in kilometer, and on x axis, we taken time in minutes. We taken time in minutes. Okay, this type of representation, if in a graph, along y axis we taken distance, along x axis we taken time. This type of graphical representation is called distance time graph. Distance time graph. ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ಏನು ಮಾಡಿದೀವಿ, y ಆಕ್ಸಿಸ್ ನಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೀವಿ ಮತ್ತೆ x ಆಕ್ಸಿಸ್ ನಲ್ಲಿ ಟೈಮ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೀವಿ. ಈ ತರ ಗ್ರಾಫ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಗೆ ನಾವೇನಂತ ಕರಿತೀವಪ್ಪ ಅಂತ ಕೇಳಿದ್ರೆ, ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಟೈಮ್ ಗ್ರಾಫ್. Okay, this distance time graph, this is for uniform motion. This is for uniform motion. Look here, where y axis and x axis, this is x axis, y axis, where they intersect. Intersect means ಒಂದನ್ನೊಂದು ಕ್ರಾಸ್ ಮಾಡೋದು. Okay, where they intersect, y axis and x axis, where they intersect, here they intersect. Okay, this is called origin. We call it as intersection point. What we call it as origin. This is also, here we also taken as, this is the reference point here. From here we measure the distance along y axis. From here we measure the time along x axis. Okay, this is what we call it as, this is also called as reference point. Okay, now here O is the reference point. From O to Y we measure the distance. From O to X we measure time. Okay, this type of measurement we taken. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, O ಇಂದ Y ವರೆಗೂ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡ್ತೀವಿ, O ಇಂದ X ವರೆಗೂ ಟೈಮ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. O is ಏನದು, ರೆಫರೆನ್ಸ್ ಪಾಯಿಂಟ್. O ರೆಫರೆನ್ಸ್ ಪಾಯಿಂಟ್. XY ಕಾರ್ಟೇಸಿಯನ್ ನಲ್ಲಿ, XY ಪ್ಲೇನ್ ನಲ್ಲಿ Y ಮತ್ತೆ X ಎಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗ್ತಾವಲ್ಲ, ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೇವೆ, ರೆಫರೆನ್ಸ್ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. Okay, look here, from O we taken along y axis distance in kilometer, 10 kilometer, 20 kilometer, 30 kilometer, 40 kilometer, 50 kilometer, like that, so on. Okay, similarly on x axis we take it time, 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50, 60 and so on. Okay, now for first 10 minutes, if a car is moving in a straight road, ಒಂದು ಕಾರು ಸ್ಟ್ರೈಟ್ ರೋಡ್ ನಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, for 10 minutes it covers a distance of 10 kilometer. For the 20 minutes, it covers a distance of 20 kilometer. For 30 minutes, it covers a distance of 30 kilometer. For 40 minutes, it covers a distance of 40 kilometer. And for 50 minutes, it covers a distance of 50 kilometer. Every 10 minutes, it covers 10 kilometer. That means this type of motion is called as uniform motion. ಹೌದಾ? ಇಲ್ಲಿ ನೋಡ್ರಿ 10 ನಿಮಿಷಕ್ಕೆ 10 ಕಿಲೋಮೀಟರ್ನ ಟ್ರಾವೆಲ್ ಮಾಡಿದೆ, 20 ನಿಮಿಷಕ್ಕೆ 20, 30ಕ್ಕೆ 30, 40ಕ್ಕೆ 40, 50ಕ್ಕೆ 50. ಎವ್ರಿ 10 minutes it covers a distance of 10 kilometer. ಹೌದಾ? ಈ ತರ ಮೋಷನ್ ಇದ್ರೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್. ಆ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ಗೆ ಏನು ಮಾಡಿದೇವೆ ನಾವು? ಗ್ರಾಫ್ ಅನ್ನು ಹಾಕಿದ್ದೇವೆ. ಇಲ್ಲಿ ಅಲಾಂಗ್ ವೈ ಆಕ್ಸಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ, ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಏನು ಮಾಡಿದ್ವಿ? ಟೈಮ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ. Therefore, what is that? This type of representation of motion is called distance time graph. Okay, here is a representation of distance time graph. Here what? For 10 minutes 10 kilometer, 20 minutes 20, 30, 30, 40, for 50 minutes 50 kilometer and so on. Okay, ಈ ತರ ಏನು ಮಾಡಿದ್ರೆ ನಾವು ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ಗುರುತುಕೊಂಡಿಟ್ಟು ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿದ್ರೆ ನೀವು, if you draw a line, okay, for these points you will always get a straight line. You will always get a straight line. Graph ಯಾವಾಗಲೂ ನಿಮಗೆ straight line ಅಲ್ಲೇ ಬರುತ್ತೆ. For uniform motion, if uniform motion object ಇತ್ತು ಅಂದ್ರೆ the line should be a straight line. The line should be a straight line. Okay, here we taken for 30 kilometer we taken distance S1, for 40 kilometer distance S2, and for 30 minutes we taken time T1, and for 40 minutes we taken time T2. Okay, from this graph, okay, here is S1 distance 1, S2 distance 2, T1 time 1, T2 time 2. Okay, here we taken S1, S2, S1 is distance 1, S2 is distance 2, T1 is time 1, T2 is time 2. Okay, from this we can find the velocity of the object. From this we can find the velocity of the object. Okay, from this point B to y axis we draw one perpendicular line, and A to y axis we draw another perpendicular line. Okay, this represents S1 and this represents S2. Similarly, from point A draw perpendicular line to x axis. Similarly, from point B draw perpendicular line to the x axis. We get 2 points there. First point we taken A to x axis perpendicular line, we taken T1, B to x axis we taken T2. Here also A to y axis we taken S1, B to y axis we taken S2. Here S1 is the distance 1, S2 is the distance 2, T1 is the time 1, and T2 is the time 2. From this we can represent, from this we can find velocity of an object. How do we find? Let's say if velocity we taken v is equal to distance by time, we know that. What is velocity is we find distance by time. Here distance is S2 and S1. Okay, that is S2 minus S1 distance divided by time, T2 minus T1, T2 minus T1. Using this equation we can find, using that equation we can find velocity of an object at any point. Velocity of an object at any point. From here, consider here, okay, here, just consider here. Just we will do one problem here. Here what is it? V is equal to S2. What is S2 here? S2 is 40. S2 is 40 minus what is S1? S1 is 30 whole divided by what is here T2? T2 is 40 minus what is T1? T1 is 30. Therefore, V equal to 40 minus 30, that is 10 divided by 40 minus 30 is 10. Okay, 10 ones are 10. Therefore, what is we get 1. 1. What is the? What is here? What we get 10 we taken. What is that? Time in minutes, and we taken distance in kilometer. Therefore, what is the SI unit? Kilometer. What is this? This is divided by minute per minute. Per, or we can write per minute. Kilometers per minute. Okay, kilometer per minute. Write minute as MIN. Kilometer per minute. Okay, the SI unit is kilometer per minute because distance we taken in kilometer and time we taken in minute. Therefore, velocity of an object is 1 kilometer per minute. Okay, this type of graphical representation is called as distance time graph. In distance time graph, distance is taken along y-axis and time is taken along x-axis, and for different values of distance, for different values of time, if we plot the graph, then it is called as distance time graph. Okay, here is the equation for distance time velocity. We can find from this graph V is equal to S2 minus S1 divided by T2 minus T1. Similarly, the next concept, distance time graph, that is non-uniform speed. If a car traveling in non-uniform speed, then how do we represent the graph? Earlier, we represent for uniform speed, we get a straight line there. Here what we see, here also we taken, O is the origin, y-axis and x-axis. Along y-axis we taken the distance in meter, along x-axis we taken the time in seconds. Okay, 5, 10, 15, 20, 25, 30, 35. Along y-axis we taken the distance in meter, 2, 4, 6, 8, 10, 12, 14, 16, 18 and so on. Time, seconds we along taken along the x-axis. Along the x-axis. You look here a graph, how it says the line of the graph. The line of the graph is different for earlier one. Earlier one, what is? It's a straight line. It is not a straight line. Okay, this type of motion, what we call it as non-uniform speed. This type of motion, okay, is called as non-uniform speed. We also represent the non-uniform speed. We also represent distance time graph. Here, how do we find the velocity? We have to find the velocity here, average distance divided by total time taken. Total time taken, or total distance divided by total time taken, or at any point, these 2 points. What is the distance traveled? These 2 points. We can take these 2 points, what is the speed, and these 2 points, what is the speed? Any 2 points. From this to this, these 2 points, what is the speed? We can find. At a different stages, it has a different speed because we have non-uniform speed. Therefore, at different stages, it has different velocity. Okay. For earlier case, we get a straight line for uniform speed. For non-uniform speed, we cannot get the what? That is a straight line. If you want to find, here we taken, if you want to find, here we taken. Okay, these are the 2 points. To find a velocity at these 2 points, velocity at these 2 points, we taken, this is S1, we taken, this is S2, this is T1 and T2. We can find the speed at these 2 points. Speed is not constant here, therefore velocity is also not constant. Speed means nothing but what? Why we taken a speed or velocity here? Speed represents for What here? The displacement is different. Okay, displacement is different, therefore a speed is also different. Here we take, that's why we take a speed here, therefore we take the straight line, therefore the minimum distance between 2 points is also same, and the so what is the actual path covered is also same, therefore in the earlier case we taken the velocity, but in this case we taken speed to find the speed. Okay, it has a different speed here, and here also different speed, okay, at every point it has a different speed, therefore the name non-uniform speed. In the non-uniform speed we cannot get a straight line. Uniform speed ittu andre straight line ಬರುತ್ತೆ ನಮಗೆ. ಯಾವುದಾದ್ರೂ ಎರಡು ಪಾಯಿಂಟ್ ಅನ್ನು ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿಬಿಟ್ಟು ಆ ಪಾಯಿಂಟ್ ನಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಸ್ಪೀಡ್ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳಿ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಸಪೋಸ್ ವಿ ಟೇಕನ್ ಎ ಬಿ ಎರಡು ಪಾಯಿಂಟ್ ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ, ಓಕೆ, ಎ ಬಿ ಅಂತಕ್ಕಂಥ ಎರಡು ಪಾಯಿಂಟ್, ಬಿ ಇಂದ ಒಂದು S2, ಎ ಇಂದ S1, ಎ ಟು T1, ಬಿ ಟು T2, ಈ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ನಾವೇನ್ ಮಾಡ್ಬೋದು, ಸ್ಪೀಡ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್, ಅವೆರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸ್ಪೀಡ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳಿ ನಾವು find out ಮಾಡಬಹುದು. Okay students, the next concept is velocity time graph. Okay, the next is velocity time graph, second concept, that is in velocity time graph along y axis we can take velocity of the object, along x axis we can take the time. Okay, in velocity time graph along y axis velocity of the object is taken, along x axis time is taken. Okay, this type of representation of motion what we call it as velocity time graph. Okay, here we taken velocity in kilometer per hour, and here we taken time in hour, and here is what, this is for uniform motion of car. ಇಲ್ಲಿ ಒಂದು ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಆಫ್ ಕಾರ್ ಇದೆ, ಆ ಕಾರಿಂದ ಏನು ಮಾಡಿದ್ವಿ, ವೆಲಾಸಿಟಿಯನ್ನು ನಾವು y ಆಕ್ಸಿಸ್ ನಲ್ಲಿ ತಗೊಂಡಿದ್ದೇವೆ and ಟೈಮ್ ಅನ್ನ x ಆಕ್ಸಿಸ್ ನಲ್ಲಿ ತಗೊಂಡಿದ್ದೇವೆ. ಈ ತರ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಗೆ ನಾವು ಏನಂತ ಕರೀತೀವಪ್ಪ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್. ದಿಸ್ ಟೈಪ್ ಆಫ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ is called it as velocity time graph. Here looking here we take it for uniform motion. For uniform motion every time the distance is, the velocity is same. Look here, here is for 1 hour 40 km per hour, for 2 hour 40 km per hour, for 3 hour 40 km per hour, for 4 hour 40 km per hour. Okay, here what is uniform motion of the car, every time the speed of the or velocity of the object is constant, velocity of the object is constant. From this graph we can find area, what is it, we can find distance traveled by the object and also velocity, change in velocity that leads to the what, that is the acceleration. We can find the acceleration of the object. Then how do we find what is that distance of the object and velocity, acceleration of the object? ಹಾಗಿದ್ರೆ ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು? ಇಲ್ಲಿ ಈ ಗ್ರಾಫ್ ಇಂದ ನಾವು ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ಡ್ ಬೈ ದ ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನು ಕೂಡ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ, ಮತ್ತೆ acceleration of the object ಅನ್ನು ಕೂಡ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಹಾಗಿದ್ರೆ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದನ್ನ? Here we taken 2 points on the line A and B. Here we taken A and B. Draw A to x axis a perpendicular line, name it as C, and draw B to x axis a perpendicular line, name it as D. AC is a perpendicular line to the x axis and BD is a perpendicular line to the x axis. Now we get a rectangle. Okay, this area of rectangle, this gives you the distance traveled by the object or distance traveled by the car. ಈ area of triangle ನಮಗೆ ಏನನ್ನ ಹೇಳುತ್ತಪ್ಪ ಅಂದ್ರೆ ಎಷ್ಟು ಕಾರ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಟ್ರಾವೆಲ್ ಮಾಡಿದೆ ಅಂತ ಹೇಳಿ ಹೇಳುತ್ತೆ. ಹಾಗಿದ್ರೆ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅದನ್ನ? ದಿಸ್ ಇಸ್ ಅ ಏರಿಯಾ ಆಫ್ ಎ rectangle. Okay, now what we have, that is velocity is equal to distance S, distance capital S divided by time taken T, divided by time taken T. Here is, this is a time 1 and this is time 2. Okay, now this is velocity 1, velocity 2, whatever you take, v1, v2. Okay, but what we want? Yes, we want. What is that S equal to? That is S equal to, how do we find? We want S. S equal to velocity into time. What is total velocity here? That is area of a rectangle. Area of a rectangle. Total velocity is area of a rectangle. Therefore, we find what is that area? Area of A, B, C, D into time taken. Into time taken. If you want to find the area of the rectangle, we want we want to find the speed of, distance of the object, distance traveled by the object, that is S equal to area ABCD into time. ABCD is the area of this rectangle. Okay, now therefore S equal to area of a rectangle, length into breadth. Here if you take the AB is the breadth and AC is the length, or you can take AC is the length, CD is the breadth, whatever your wishes. Okay, that is AC into, what is that? AC into CD, length into breadth, whole bracket into time. What is the time? T2 minus T1. T2 minus T1. This gives you the distance traveled by the object. This expression, area of a rectangle into time taken, gives you the distance traveled by the object. Distance traveled by the object. Okay, now next we can find the acceleration. Acceleration of the object. What is the acceleration? How do we find the acceleration of the object? If we take this one is v1 and if we take this two is v2. We know that acceleration is a change in velocity with respect to time, right? Therefore, acceleration A equal to v2 minus v1 divided by t2 minus t1. This gives you the expression of acceleration. Here what? There is no change in velocity. Velocity is constant, 40 km per hour. Therefore, what we get? The acceleration in this condition for uniform motion of a car, the acceleration is 0. Okay. OY ನಲ್ಲಿ ನಾವು ವೆಲಾಸಿಟಿ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ, OX ನಲ್ಲಿ ನಾವು ಟೈಮ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ. ಈ ತರ ಗ್ರಾಫ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಗೆ ನಾವು ಏನಂತ ಕರೀತೇವಪ್ಪ ಅಂತಂದ್ರೆ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ಅಂತ ಹೇಳಿ ಕರೀತೇವೆ. ಹಾಗೆ ಇಲ್ಲಿ ನಾವು ಎರಡು ಪಾಯಿಂಟ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ, ಎ ಬಿ ಅಂತಕ್ಕಂಥದ್ದು ಎರಡು ಪಾಯಿಂಟ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ. ಎ ಟು ಸಿ ಗೆ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿದ್ದೇವೆ, ಬಿ ಟು ಡಿ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿದ್ದೇವೆ. ನಮಗೆ ಗೊತ್ತಿದೆ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಡಿಸ್ಟೆನ್ಸ್ ಬೈ ಟೈಮ್ ಟೇಕನ್. ಓಕೆ, ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ, ಅವರೇಜ್ ವೆಲಾಸಿಟಿನ ಹೇಗೆ ಫೈಂಡ್ ಮಾಡಬೇಕು? ದಟ್ ಗಿವ್ಸ್ ಯು ದ ಅವರೇಜ್ ವೆಲಾಸಿಟಿ, ಟೋಟಲ್ ವೆಲಾಸಿಟಿ. ಇಲ್ಲಿಂದ ಎ ಇಂದ ಬಿ ವರೆಗೂ ಎಷ್ಟು ಇದೆ ಟೋಟಲ್ ವೆಲಾಸಿಟಿ, ಅದನ್ನ ಹೇಗೆ ಫೈಂಡ್ ಮಾಡ್ತೇವಪ್ಪ ಅಂದ್ರೆ ವಿ ಟೇಕ್ ಅನ್ ಏರಿಯಾ ಆಫ್ ಎ rectangle. Area of a rectangle. Area of rectangle ಏನು? Length into breadth. You have the equation. Area of a rectangle is equal to length into breadth. If AC is the length and CD is the breadth. Okay. If AC is the length, CD is the breadth, then S equal to what? Area of a ABCD. ABCD is a rectangle. Area of a ABCD. ABCD is rectangle. S ಅಂದ್ರೆ ಏನು? Distance. Distance is equal to area of rectangle ABCD into what is the time taken. What is the time taken? ಹಾಗಿದ್ರೆ therefore distance is equal to AC into CD, length into breadth. Area of rectangle into T2 minus T1 is the time taken. Therefore from this equation S equal to AC into CD, T2 minus T1. From this equation we can find the distance traveled by the object, and also from this graph we can find the acceleration of the object. ಹೇಗೆ acceleration find out ಮಾಡ್ತೇವೆ? A is equal to change in velocity v2 minus v1. ವೆಲಾಸಿಟಿ ಎಷ್ಟು ಚೇಂಜ್ ಆಗಿದೆ ಡಿವೈಡೆಡ್ ಬೈ ಆ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಚೇಂಜ್ ಆಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ಅನ್ನು ತಗೊಂಡಿದೆ, T2 minus T1. Therefore A is equal to v2 minus v1 divided by T2 minus T1 gives you the acceleration from this graph. Okay, just we will find the what is that? Just we will find S here. S here. What is S equal to AC into CD? What is AC here? What is AC? A to C. How much? 0 to 40. How much is that? AC is 40. AC is 40 into what is CD here? What is CD? C to D. 1, 2. Okay. 1, 2. How many hours? 1, 2. 2 hours. 4 ಅಲ್ಲಿ 2 ಹೋದ್ರೆ 2 hours. ಹಾಗಿದ್ರೆ ಎಷ್ಟಾಯ್ತು? ಇಲ್ಲಿ 0 to 40 40 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಇದೆ AC and CD ಎಷ್ಟಿದೆ? 2 hours ಇದೆ. 1, 2 2 hours. Okay. 40 into 2 into bracket T2 minus T1. T2 minus T1. T2 is 4. T1 is 2. 4 minus 2. Okay. Therefore, what is the total distance traveled? 40 into 2 is 80 into 4 minus 2 is 2. Therefore, S is equal to 80 into 2. 80 into 2 is 160. What is that? Distance always measured. Here given in kilometer, therefore distance measured in kilometer. Hagidre from this graph, the total distance covered by the object is 160 kilometer. 160 kilometer. Adadre acceleration annu find out madbekadre neevu A equal to acceleration find out madbekadre A equal to V2 minus V1. V2 ಎಷ್ಟಿದೆ? 40 ಇದೆ. V1 ಎಷ್ಟಿದೆ? 40 ಇದೆ. Therefore 40 minus 40 divided by time ಎಷ್ಟಿದೆ? That is 4 minus 2. That is 40 minus 40 is 0 divided by 2. 0 by 2. 0 by anything is 0. 0 by anything is 0. Therefore A equal to 0. Therefore A equal to 0. 0 by anything is 0. Therefore A equal to 0. ಹಾಗಿದ್ರೆ ಇಲ್ಲಿ ಏನಾಯಿತು? Acceleration ಏನಾಯಿತು? Acceleration is 0. But total distance ಏನಾಯಿತು? Total distance 1 kilometer, 160 kilometer ಆಯಿತು. Okay. ಹಾಗಿದ್ರೆ ಏನು equation for finding the distance from velocity time graph? That is S equal to AC into CD into bracket T2 minus T1. AC into CD is nothing but area of a rectangle. Area of a rectangle. Therefore, AC is equal to AC into CD into bracket T2 minus T1. You can also find the acceleration. That is the equation is V2 minus V1 divided by T2 minus T1. Okay, students. Similarly, the velocity time graph, that is for uniform acceleration of car. Uniform acceleration of the car. In the previous, we discussed what is that? Uniform motion of the car. Here, uniform acceleration. Uniform acceleration. Uniform acceleration means what? At every time, the acceleration is constant. For a particular time, the acceleration is constant. Then it is called as uniform acceleration. Look here. For 5 seconds, acceleration is 10. For 10 seconds, acceleration is 20. Here to here is time is 5 seconds. Here to here is 10. What is that? Kilometer. Here we taken velocity kilometer per hour. Here we taken kilometer per hour and time we taken here in seconds. Time we taken in seconds. Look here. 0 to 5, 5 seconds. 5 to 10, 5 seconds. 10 to 15, 5 seconds. 15 to 20, 5 seconds. 20 to 25, 5 seconds. 25 to 30, 5 seconds. And here also the velocity is 10 km per hour, 10 km per hour, 10 km per hour, 10 km. Every interval, 8 to 10 km per hour. Okay. For 5 seconds, 10 km per hour. For 10 seconds, 20, 15, 30, 20, 40, 25, 50 up to so on. Okay. Here what is taken? ಇಲ್ಲಿ ನೋಡ್ರಿ 0 ಇಂದ 5 10 km per hour ಇದೆ. 5ರಿಂದ 10 10 km/h ಇದೆ, means 20 minus 10 is 10, 10 minus 5 is 5. ಹೌದಾ? ನೀವು ಡಿವೈಡ್ ಮಾಡಿದರೆ ವೆಲಾಸಿಟಿ ಮತ್ತು ಟೈಮನ್ನು ಡಿವೈಡ್ ಮಾಡಿದರೆ ಎವ್ರಿ ಪಾಯಿಂಟಲ್ಲಿ ಎಕ್ಸಿಲರೇಷನ್ ಏನು ಬರ್ತಾ ಹೋಗುತ್ತೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಬರುತ್ತೆ. ಆ ಥರ ಮೋಷನ್ ಇದ್ದರೆ ನಾವೇನಂತ ಕರಿತೇವೆ, ಯೂನಿಫಾರ್ಮ್ ಎಕ್ಸಿಲರೇಷನ್. ಯೂನಿಫಾರ್ಮ್ ಎಕ್ಸಿಲರೇಷನ್ ಅಟ್ ಎನಿ point of this line, okay, the straight line, the acceleration is constant, then it is called as uniform acceleration of a car. Okay, now here for uniform acceleration you are seeing a straight line, you are seeing a straight line. Then from this graph, how do we find the distance traveled and acceleration of the object? How do we find distance traveled and acceleration of the object? That we will see. Okay, here we have two areas. Look here, distance is equal to area into time taken, right? Here we have two areas. One is a triangle and another one is a rectangle. ಇಲ್ಲಿ ನೋಡ್ರಿ ADE ಇದು ಟ್ರಯಾಂಗಲ್ ಇದೆ ಮತ್ತೆ ABCD ಇದು ರೆಕ್ಟಾಂಗಲ್ ಇದೆ. ಇಲ್ಲಿ two areas ಇದಾವೆ. two area ಇರೋದ್ರಿಂದ ನಮಗೆ ಏನು average total velocity ಎಷ್ಟು ಅಂತ ಬೇಕು. average total velocity into time is distance. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಬಂತು ಇಲ್ಲಿ ಏರಿಯಾ? that is we have to find S is the distance is equal to area. area ಎರಡು ಏರಿಯಾ ಇದಾವೆ ಇಲ್ಲಿ. ಯಾವ್ದು? area of ADE area ADE. This is area of triangle ADE plus ಎರಡಿದಾವೆ. ಇದನ್ನು ಮತ್ತೆ ಇದನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ ಟೋಟಲ್ ಏರಿಯಾ ಸಿಗುತ್ತೆ ನಮಗೆ. ಇದು ಏರಿಯಾ ಆಫ್ ಎ ಟ್ರಯಾಂಗಲ್ ಮತ್ತೆ ಏರಿಯಾ ಆಫ್ ಎ ರೆಕ್ಟಾಂಗಲ್. ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ADE, ಏರಿಯಾ ಆಫ್ ರೆಕ್ಟಾಂಗಲ್ ABCD. ಏರಿಯಾ rectangle ABCD, area of rectangle ABCD. Okay, now into time gives you the distance. Therefore what is that? This into time, this into time gives you the what term? Okay, I'll write once. Just see, what is S equal to area triangle ADE plus area rectangle ABCD into time, gives you the total distance covered by the object, gives you the total distance covered by the object. S equal to area of triangle ADE plus area of rectangle ABCD into time. ಟ್ರಯಾಂಗಲ್ ಮತ್ತು ರೆಕ್ಟಾಂಗಲ್ ಎರಡನ್ನೂ ಕೂಡಿಸಿದ್ರೆ ನಮಗೆ ಟೋಟಲ್ ಏರಿಯಾ ಸಿಗುತ್ತೆ. ಹಾಗಿದ್ರೆ therefore S equal to area of triangle. What is that area of triangle formula? Yes, in the 8th standard we discussed half into base into height, half into base into height. ಈ ಟ್ರಯಾಂಗಲ್ ನಲ್ಲಿ ಬೇಸ್ ಯಾವುದು? AD is the base. Okay, area of triangle half BH, base into height, and plus area of rectangle length into breadth, length into breadth into time, right? Okay, now therefore S equal to half base ಏನಿದೆ ಇಲ್ಲಿ? base of the triangle ADE is a triangle, base of the triangle is AD into height of the triangle is DE, height, this is the height of the triangle DE plus length into breadth, rectangle AD ABCD, rectangle length AC AB into BC, AB into BC into time, you know, T2 minus T1, time is T2 minus T1, T2 minus T1. If you do, this is the equation for distance traveled by the object. Distance traveled by the object. Similarly, we can also find acceleration, that is v2 minus v1 divided by t2 minus t1. From these two equations, we can find the distance traveled by the object and acceleration of the object. Similarly, the next concept in velocity time graph, that is non-uniform acceleration. Non-uniform acceleration means acceleration is not constant, acceleration goes on varying. That is called as non-uniform acceleration. Acceleration ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಯಾವಾಗಲೂ ವೇರಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. acceleration ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಲ್ಲ. ನೋಡ್ರಿ ಈ ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ acceleration ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ನೆಕ್ಸ್ಟ್ ಈ ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಲ್ಲ, ಈ ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಲ್ಲ, ಈ ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಲ್ಲ, ಇಲ್ಲಿಲ್ಲ, ಇಲ್ಲಿಲ್ಲ. ಏನಾಗಿದೆ ಇಲ್ಲಿ acceleration goes on varying. That type of motion is called non-uniform accelerated motion. Non-uniform acceleration motion. Here velocity we taken along y-axis in meter per second and time in second along x-axis we taken. Look here, how is the line? Is it a straight line? Uniform ittu andre yavaglu namage straight line sigute. Uniform illa andre enagutte namage straight line sigalla. This is not a straight line motion. Okay, this is not a straight line motion. This is what we call it as the representation of motion, that is non-uniform acceleration. This type of graphical representation is called velocity time graph. Okay students, we will continue in the next class.